Hi, welcome back. In this lecture, I want to discuss a very important practical aspects when using supercomputer. It's important that you understand what we are doing. So we have a list of commands that are going to use it. I want to spend a little time with you to go through why we are doing that number of commands. I want to give you a big overview of what's going on at a supercomputer. So when we run a supercomputer, the supercomputer itself is constituted by a large number of computing nodes where the actual simulation is done. So the simulation, and also when we are going to run our assignment on one computing node, will be this blue part here. So we are only allowed to run our simulation on the blue part here. Together with these blue computing nodes, they provide a means to do our calculation. A supercomputer always have the so-called login nodes. It might be one or multiple login nodes. So whenever we do SSH, then the name of supercomputer at, for instance, pdc.nada.kth.sc, we will be prompted in one of these gray login node. So these are big nodes that allow us to connect, right? So as a user, we are here in this all. We are going to use a Kerberos to authenticate, and then we are going to connect using the Linux command SSH, and we will connect to these login nodes. We'll see then that we have so-called scheduler or workload manager called SLAM that will allow us to launch from the login nodes our executable to run on the computing nodes. So this is the big picture of a supercomputer. We are here on the left. We do Kerberos, we authenticate with Kerberos, then we type SSH, and then we connect it to the so-called login nodes. Once we are on the login nodes, we can compile. We can only compile on the login nodes, but we cannot run. Absolutely is forbidden. We use a Slurm to launch our code to the supercomputer computing nodes. So the first step is to connect to the login nodes. We use the command line. We install and set up Kerberos, that is a software to authenticate ourselves on the supercomputer, and run instruction on canvas on how to do that. Then we will use the Linux command SSH to connect to the supercomputer via the command line. It's important to realize that when we do SSH, we are actually on the login nodes, so the gray box here. It's important to think that login nodes are shared nodes across all the users. So multiple users will, when connecting to the supercomputer, will all share the login nodes. So it will be myself, and then it will be other students from DD2356, and it might be also other research. They all do SSH, they will connect to the supercomputer, and they will be all together on the login nodes. This means that these nodes are basically shared across multiple people. So for instance, after you did the SSH, you can just use the top command, and you will see a list of the people that are actually on the login node. It's important that we use the login nodes only for compiling our code, right? So don't never ever use the login nodes for running your executable. So it will be very tempting after you compile, you get executable, and then just type the name of your executable. But in that case, you won't run on the supercomputer, but instead you will run on the login nodes. So why never ever use the login nodes? Well, if you run your simulation on a login node, basically you are going to slow down, use all the resources on the login nodes that is shared with other people. So other people that try to compile will be super slow. The node won't be responsive. They will complain massively with the system administrator of the supercomputer. In addition, if you try to get performance out for your assignment, you will get performance results about your login node and not the supercomputer itself. Never ever use the login nodes for running your executable, just for compiling. So how we run a simulation on the supercomputer? We need to use a so-called Slurm, that is a workload manager, that is a scheduler. A Slurm allows us to launch our simulation on the computing nodes, on the supercomputer, the blue boxes. Slurm allows two kinds of jobs. One is interactive modes, so we just ask for a source. For instance, we ask for one computing node, so just one. You will see on Canvas on how you do it, and then will be prompt to a terminal whenever, as soon as the computing node is available. So we can probably wait a little bit, and then as soon as nodes become available, will pop up in our terminal that now you have this login node and you can launch your simulation, still using srun. The other mode is called the batch mode. That means that we compile our code and then we put on a queue. We decide how many resources that we need and we put in a queue. So we write a script to put in a queue. We write a Slurm script. So what is the difference? Well, we typically have interacting mode only for small jobs. If, for instance, we need one node, two nodes maximum, mostly for debugging reason. So you want to interact with the code. Whenever we had a large number of, we need a large number of resources, then we need to use the batch mode. So we will need to put our simulation on a queue, and this will be run as soon these resources are available. We always need an allocation or a project number to run a supercomputer. So we have an allocation number, a project number that you will need to use when run a simulation. So as a part of this course, I've made an application to get an allocation, and then you will need to put this name in your allocation when running the code. A last very important part when using Dardel, the KTH system, is important to realize that KTH PDC using two file system. One is called AFS and the other one is called CFS. So whenever you do SSH, you will log in the login node, and your file system will be the AFS. And the important part of this is that when we run on our computer, on the supercomputer, so we use a Slurm. At this point, we have our simulation running on the compute nodes. It's super important to know that the computing nodes only have access to CFS. File system, so it cannot access to AFS. That means that if you're running a simulation and then you try to write or to read an input file, or most importantly is try to find the executable here on the AFS, because you have only on AFX, you will have an error, right? Because the computing nodes cannot find the executable or the input file. So this is not good. So whenever you run on a supercomputer, your executable must be on CFS. So I strongly recommending, for instance, when your login node, you will be in AFS. I recommend you to move. For instance, you do a command cd to CFS, and then you can compile there. Your executable will be on CFS and will be reachable by your computing node. So it's important that you know that your executable must be on CFS, and when you do a login, you will be right away in AFS, but you need then to change to CFS. So this is the last slides about this lecture on practical aspects of assessing supercomputing here at KTH, and talk to you soon.